Welcome to the session, Developing Metrics to Support Shared Research Resources. So our speakers today are going to be Chris Gregory, Jeff Weiss, and Kim Kirkpatrick. I'll introduce them in a little more detail in a minute. I think it's really important to think about, in our line of work, the purpose of metrics, because they take a lot of work to maintain. And to me, they fall into one of two buckets. So they're either there to advocate and advertise. So think about yourself driving down a road. You drive by a greasy hamburger stand and you're wondering if it's a good place to go or not, right? Oh, that's small. So if it's served a couple million hamburgers, maybe you think, yeah, I could stop there. It's probably safe, right? This one says 248 billion sold. That conveys a different message for you, right? So you have to be careful about how you make your metrics. One set of metrics that we all are probably familiar from in terms of learning and making a decision. So if you've been in an S10 grant review, so this society, right, said that there should be some metrics regarding the performance of the institution in supporting past S10 grants. And right, so there's a table that's included in every S10 proposal where you have to describe, all the instrumentation from the last 5 years, right? Is it available, right? Is it under service contract? How many hours was it used last year? How many citations have been made? So these are metrics that they're painful to pull sometimes, right? Because you got to reach out to all the people. You got to convince the faculty to cite the paper or the grant. Sorry. And so this is an example where we as a group have decided that these metrics are really important in making decisions, right? And they get used, right? So, I've seen both sides of this review process where it's helped and hurt grants. And so, you can start to see, places where you're going to use metrics to either advocate for yourself or hopefully learn. So to make a good metric, right, so one, it needs to be simple. It needs to resonate with folks. So, how many hours did someone use the piece of equipment? That's something that we all understand, right? So it's something that you can see and make a judgment very quickly. It has to be actionable, right? So the things, you have to have input into the metric for it to be valuable, right? Because otherwise it's just a number that's free floating regardless of what you do. You want it to be robust, right? So you don't want a lot of noise in your metric for similar performance. And it has to be maintainable. And this one's hard, right? We put a lot of effort into collecting this data and curating it and making sure that it translates from one year to the next, right? It's not something that you can put together 5 minutes before a presentation to try to advocate for some resource, right? And so you're gonna put this work in up front, knowing that you're gonna use that metric for a wide variety of tasks. And so, I think about this idea of vanity metrics, right? So maybe the 248 million or billion hamburgers sold starts to fall into that mode versus actionable, right? You need to look at, what the metrics are doing for you, right? And how they work. One of my favorite ones, so it's a New York Times article on Stanford's acceptance rate. As a little bit of the punchline first, this was published on April 1st, right? But the idea was Stanford accepted 0 students so that they could say that they're the most exclusive university, right? And And so, that kind of metric can make you feel good, but isn't going to help in terms of advocating for resources. It's not going to help you learn anything about your processes. So what we wanted to do in this presentation is talk about how leadership views metrics and what we use them for, with the idea of, one, convincing you that, hey, these are a good thing to be collecting, and can help advocate for you, but also to help get feedback from you on, what type of information do you need to make good decisions going forward. And so the idea is really to pull back the curtain on our side, because we do have time to curate metrics, right? And we have some breadth across all the cores to do this. And so, this hopefully will be an interactive discussion after the first 50 minutes. Oh, no. My computer went to sleep. I heard someone was telling bad jokes in the last section. I started it too soon. Well, what I will do is I will drop this one. So there's going to be 3 presentations. So Christopher Gregory is a professor, director of research, and associate chair for administration in the Department of Genetics at the University of North Carolina at Chapel Hill. He serves as the director in the Office for Research Technologies for the UNC School of Medicine, with administrative, operational, and financial oversight of almost 100 shared resources. Today, he'll be presenting on how to demonstrate the scientific impact of shared resources through effective identification of publications, including peer-reviewed papers, dissertations, patents, using a new automated search tool being developed at UNC. After that, Jeff Weiss is the Director of Core Planning at Northwestern University, Feinberg School of Medicine. He assumed the role in 2008 after 2 decades as a reproductive biologist, during which he was an active consumer of core services. In his current role, he oversees a program that provides guidance, administrative oversight, and financial support for a group of about 30 core facilities. He also founded and continues to participate in the oversight of the New Core Consortium, a group of universities that uses core facilities management platform initially developed at Northwestern. Jeff will be presenting on how leadership views return on investments, supporting core operations, and justification for continuing support. And lastly, Kim Kirkpatrick is the Associate Vice President for Research and Innovation in charge of research capacity building at the University of Minnesota. And she provides leadership and development. Sorry. I lost my page. Research infrastructure and resources, including the Research Animal Resources Facility and Biosafety Level 3 program. She more broadly oversees university shared research resources and core research services, and she directs the Research Infrastructure Investment Program. Prior to joining the University of Minnesota in June 2023, Kim was a distinguished professor of psychological sciences and director of the Cognitive and Neurobiology Approaches to Plasticity Center at Kansas State University. And Kim will be discussing how metrics are used to make strategic decisions regarding the offering of services. So Chris is up first.
Thanks, Andy. So I'm going to make a wild assumption that a few of you in the room may have challenges with tracking publications for your course. So that's a valid assumption. All right, I thought it might be. So about 6 or 7 years ago at UNC School of Medicine, we decided we better start paying attention to this. And there were some simple tools out there to track publications. And we started an initiative where we were paying attention to it a little bit more. And sorry, it's not advancing.
Try again. I was using this guy.
Get some tech support.
Advances. There you go.
All right. Do I use the buttons or the remote? All right, so why is this important? That's probably a question that we've all asked. I think we probably all have our own set of answers of why it's important to track publications associated with cores. But as you know, and you work in these, and you probably do a lot of this work, the shared resources generate much of the data and or perform the data analysis for all of these peer-reviewed publications, as well as the grants that are submitted. The people that work in shared resources may not be included as co-authors. And if that's happened to you, I'm sorry. That should never be the case. The scientific impact in an academic setting is reflected by the number, the quality, and the citation index of primary research articles. This is the coin of the realm in academic science, right? It's the number of papers, hopefully highly impactful papers that the labs publish. And then I think it goes without saying, and I think will be illustrated as we go through this session today, that strategic investment decisions for our cores should be driven by these ROI data, or return on investment data. And we're going to hit on a lot of these as we go through our talks today. So demand for the services, how happy are the customers that are using the cores, the grants that are supported, the quality of the data that's generated. Financial management is very important, the technologies that are available, and I'm going to talk about publications today. So what are some of the challenges? First of all, a lot of times, too often, shared resources are just not acknowledged. The core is not called out anywhere in the paper. The instrument may be named in passing as a confocal microscope somewhere at UNC Chapel Hill. And I don't know about you guys, but we have a lot of those. And so that becomes a challenge. So there's no proper acknowledgement of the core. Frustrating, yes. There's a lack of consistency in the naming conventions if they are acknowledged. And I'm going to give you a case study in just a moment to show you that one of our microscopy cores went by 10 different names. It didn't. It only had one name, but 10 different names were used in the literature. And so the lack of consistency is a huge problem when we're trying to set up ways to make sure we find these publications. You may or may not have this. So a lack of standardized, structured information on shared resources is everything in one place where all of the people that work in the core are listed, all the instrumentation is listed specifically, the name of the core is accurate, and it's all in one place. And so I can develop a search string from a consistent, standardized, structured piece of information. If you've ever done this using a manual search process, you know that it can be very time consuming, right? And so a lot of times it becomes, I just don't have time for this. I'm a core of one. How do I have time to set aside to go and do a manual search process for papers that I may or may not have been mentioned in? And so it becomes one of those challenging things that falls way down the priority list. There are multiple publication databases out there, right? So PubMed, Google Scholar, Scopus Web of Science, Dimensions, pick your favorite. But which one are you going to use? Are you going to use them all? Are you going to pick one and go with it? And then there's the FOMO, right? What if I don't use that one? I might miss some papers, and I need to get them all. How about this? The shared resource depends on self-reporting by the PIs. How many of you chase PIs to get the papers they published that used your core? Yeah, I see a lot of hands. And so a lot of us rely on that. And that is only as effective as the PI has time, to do it. And they don't keep track of it either. And so that becomes unreliable. How about silos? A lot of cores are in departments or centers or different schools. And so that becomes challenging because they may collect them one way and the school may collect them another way. And if you're not a centralized structure where you have access to all of those, you may not see the full data set, and so it's incomplete. And then duplicate results, and I'm going to talk to you a little bit more about this, how that happens, but depending on how you use your search strings, if you're using the names of the core directors, if you're using the confocal microscopes in those cores, if you're using a PI search to see if that cross-references with the core, you may end up with a bunch of different duplicates, right? And you don't want all of that noise in your system. You just want to get the one accurate result. And then what about when people come and go? We know we have a lot of turnover in our core labs, and so you have to keep track of the people working in the cores if you're going to use their names to do the searches. And so the changes in leadership, the changes in staffing over time, those are really important things to keep track of. And again, that goes back to this idea of having a standardized, structured database. You may have other challenges. These are the ones that we've identified and that have been real pain points at UNC Chapel Hill. So, as I mentioned, 6 or 7 years ago, we started tracking this just using a simple PubMed search with the name of the core. Just automated, feeds us the papers every week. And it was very unsatisfying. I knew that with 100 cores in the School of Medicine, we must be generating more papers than we're actually picking up. And so we set about trying to figure out how to improve this. And as we started working on this process, we had a lot of key learnings that's informed how we've been doing this since. So I talked to you a little bit ago about a case study of naming conventions. Here's our Microscopy Services Laboratory. That is the official name of the core. And so we did a search with that plus UNC plus the center grant, the P30 grant number that this core is associated with. And so, as I mentioned in jest, but it's a pain, there are 10 different names of the Microscopy Services Laboratory in the literature. And we wanted to make sure we didn't miss any, right? So you had to do all those iterations. Those are the ones that came up when you went and did this kind of a search. We've had a lot of people come and go, and they're not all named the same, right? So Robert might be Bob in one paper and might be Robert in another paper. And so you have to think about the iterations of the staff or the directors. The equipment is fairly standard as long as you use the equipment manufacturer and the name of the equipment. So that one is less problematic. And then the equipment identifiers. So the RID, if they have one, or the grants associated with that particular piece of equipment. So the other key learnings we had is that the manual process of curation, because of 10 iterations of a core's name, required a ton of time. It really required a lot of effort. This was non-automated, and so I couldn't stay current. It wasn't useful to push a button and say, okay, here's my current report. I have to go through this process every time and eliminate all of these duplicates and all of these different iterations. False positives we found were a real problem. So you may have this issue at your institution. There are multiple instruments of the same model in different cores at UNC Chapel Hill. Okay, and I've just used confocals. I could as easily say mass specs because they're all over the campus and they're the same model. And so if I search using that piece of equipment's name, I may pull up 3 cores. And so then I have to sort out using another part of the search to figure out which one it is. There are similarly named core facilities at other UNC institutions. We have 17 universities in our state university system. And so it may pick up a core at UNC Wilmington or UNC Charlotte if I didn't build it in with UNC Chapel Hill. And so I might get a false positive there. There are some core directors who are PIs in their own right. They have their own R01s, right? They just happen to be a core director as well. Well, they're publishing papers as a PI, and they may not have used that core, but if I use their name to search, I get a hit that may not have involved the core. Okay, so that's an invalid paper for a core. And then we have, and this may be true for you as well, multiple core facilities at Chapel Hill that offer similar services. Yeah, it shouldn't be the case, but it is. And so there's some duplication, and so then it becomes an issue of parsing out which one is it when I find the paper. And so what we left with after all of these key learnings, which was a lesson that you should cast a wide but very specific net when you do these searches. So what do we mean by that? So when we started out, as I said, 6 or 7 years ago, we were using PubMed. Using the NCBI tool, maybe some of you have used this, and all we had was the core name and UNC Chapel Hill. And the search string captured data at that time for about 50 cores, and we had really one identifier for the core. It was the name. And it had to be the exact name, right? So you know that wasn't going to work for Microscopy Services Laboratory because they have 10 different names in the literature. So that was a problem right out of the gate. And so we started a new comprehensive method to use way more identifiers per core. And you can see here, for 64 different cores, when we started this work 2.5 years ago, we had actually 4.6 plus 2.4 identifiers per core facility. That's way more robust than one, right? Just the name of the core. And so in 2021, we just looked at the old method versus the new method. And so the PubMed strategy with just the core name identified about 108 papers in a year for 100 core facilities in the School of Medicine. We knew that couldn't be right. And so when we widened our aperture here and did a more robust type of search with more identifiers, we actually saw a 12-fold increase. Okay, that felt right. 1,300 papers published associated with 100 cores. And so it just shows you the dramatic difference if you expand the number of search terms. It doesn't mean that it's easy because you have to figure out still what all those duplicates are going to do to your results. But what I can say is that since 2017, we went back and reran all of these searches back through the literature that our cores have been cited more than 1,000 times per year since 2017. And that's an important metric because those are verified papers that use cores at UNC Chapel Hill. We were getting 100 a year. Now we're getting more than 1,000 a year. Okay, so this was the manual version. A lot of manpower. So how do we automate this? And this is where we are right now. The idea here being that the core takes an active role in building their own profile. They know the best of what terms should be in the profile. We set up an automated search for publications, figure out a way to verify the results, and then they can generate a dashboard. So this is what we're doing. We are in the middle of a 25-core pilot right now for this automated process. And this actually benefits another core at UNC Chapel Hill. We have a data science, data visualization core that we contracted with to say, we need you to help us build out this tool. Because we figured out a way manually to do this, we'd really like to see it automated. So what will happen here is that the core director, core staff, will build a shared resource profile annually. They'll set up their profile. And the key information that they will include for their profile would be the people that work in the core, the services they offer, the equipment they have in the core, any new or existing grants, the numbers, and any RRIDs that they may have. The search terms will then be generated from that profile that they've built, and then values assigned to the relevance of those terms. So the idea here is to use machine learning over time and AI so that these searches become really smart. But that requires some upfront work to where we have to help the computer understand what a verifiable result looks like. And so that's where we're at right now. The verification step it's informed by the search method and the frequency of the terms. So there's a part of the algorithm that uses term proximity. And the search algorithm becomes smarter the more input that you give it. And so we use a REDCap database to facilitate this verification. and the feedback is then incorporated into the data sets. So we've done a search, gone through and verified the results. These are all good hits, these are not. Enter those back in and say, this is a good search string for this particular core. This is not a good search string, or these terms don't matter. Ignore those. And then the idea is over time, machine learning is going to reduce the manual curation, or the manual verification that has to be done. And there's going to be a score assigned. So if it's a good term proximity, it's going to get a good score. It's going to be counted. If it's medium term, it might say this one could be a little bit iffy, or if it's a bad one, it just gets kicked out. And so the only ones you have to worry about looking at would be the ones that are kind of iffy, right? That there needs to be a little bit of manual curation to check it out. So what can you get out of this? This is an example of a dashboard that we can generate, which will include all the identifiers of the core, but also all the details of the publications associated with that core for any time frame. So the authors, the journals, the research areas, the funding organizations, citations themselves, and the idea is that they can go in anytime, punch a button, and it'll pull a report. So anytime your annual report's due for your CCSG or whatever it might be, you can go in, pull the report, roll it up. The other thing is ways to look at the research impact. How many eyeballs are on this paper? And so there are ways to go out there now and say that this paper, somebody on Twitter is blowing this paper up right now. And so you'd like to know that somebody is actually looking at this and they're passing it around to all their friends. And so there are ways through altmetrics to be able to go out and say, where is this paper showing up? It's in these blogs, it's on Twitter, it's in all of these different places. And you can get a report for that. And there's also citations we talked about a little bit earlier. So there's a relative citation ratio, which you may be familiar with, RCR. There's also a field citation ratio. And over here on the right, this is just an example of a bunch of papers. And this is plotting the FCR versus the RCR. And so that red dot way up in the right corner, that means that is a highly cited paper in the field. And it also has a very strong citation ratio compared to other papers that are funded by NIH in that area. And so you can demonstrate actual strength of citation from these kind of reports. So we're also working on ways to aggregate reporting. And so you may have structural biology cores, and you want to run all the metrics for those 7 cores or whatever. You can get a report just for your structural cores, or your genomics cores, or something like that, or individual reports for each of the cores. So that's the idea that we're trying to get at. So there were some huge added benefits that we did not anticipate. If you're at an academic institution, then you have a mission, and our tripartite mission at UNC is research, clinical excellence, and education. Cores are hugely impactful for education. And I don't know if we've ever thought about it that way. So you can not only roll this up to a dean for research, but also on the educational side with the curricula to make sure that the folks that are managing our graduate student programs appreciate the value of our cores. And so when we looked at that same number of 64 cores, we found that there were actually more than 2,600 acknowledgments of those cores in dissertations and theses at institutions around the world through last year. And I'll show you a map in a minute what I mean by that. But 25% of those dissertations acknowledged more than one core at UNC Chapel Hill. And 86% of the acknowledgments were for dissertations and theses awarded across 8 different schools. So we have a wide reach at our own institution, but also globally. And there were over 200 distinct universities that had dissertations published that utilized a core facility at UNC Chapel Hill. And that just blew my mind. I had no idea that there was that kind of reach. We also were able to discover more than 100 patent applications submitted in the last 12 years or so that actually cited a core. So the cores are helping to generate intellectual property as well. And that's hugely impactful for an academic institution. So here's the geographic reach of UNC cores, which we just didn't anticipate. So you can see a lot of use by European institutions, South America, Asia, and then Australia and New Zealand. When we showed this to the leadership, you know, they're also flabbergasted. We had no idea that our cores were being utilized globally like that. So why is all of this important? And I'm going to close with this. This particular metric, I know we all have a lot of frustration with, but it can be used in so many different ways with so many different types of leaders. And I'm going to actually start down here at the bottom and work my way up. So students, obviously, they're using our cores in their dissertation research, right? And so if they can see a bunch of papers that were published using the high-throughput sequencing facility, they know that's where I need to go to get my sequencing done. And so the papers that are published and that we're identifying actually helps the students with their education. Core directors, there's so many ways that you can use this particular metric. So it shows the impact of your core, the scientific productivity of your core, hugely impactful. The return on investment, when you can go to your chair or your center director or your dean and say, look what your little bit of subsidy is getting you, right, as far as the return on investment. Growth of your core over time, you'll be able to plot this, the number of papers generated. And then something that I want to be sure that we don't gloss over is you can use this for your promotion. If you're faculty, this is one of the metrics you can say, look at how many papers my core was involved in. And you should get credit for that, right? And even if you're not faculty, you want to promote the folks in your core as staff, you can use this metric for that as well. PIs, they're going to want to know which cores are best to enable my team science project, right? There's a lot more UM1s and UO1s being funded these days, and they want to know which cores. And a lot of those large team science grants use 5 or 10 cores. And if they can find those in the literature, then they're going to want to use those as well. Annual reporting for chairs and center directors. Obviously, we all know that that's important. We all hate when we get that email. It's like, I need to have that report now. You know, the annual Cancer Center grant report is due in 2 weeks. Give me the papers. Hopefully, we'll make that easier. The deans that decide on how the dollars get spent. This is an important metric that we can offer to help them make their decisions of where they should invest their dollars. The VPRs, VCRs, strategic decisions for new technologies. That's incredibly important if we're going to stay on the cutting edge, if not bleeding edge, of new technology. Cores should be where that happens, and these publications help generate that interest. How about the legislature? State budgets for research. North Carolina is unique in UNC Chapel Hill in that we have a huge University Cancer Research Fund that's funded by the tobacco settlements. No? Okay. You know, bad money is used for good. And so we get a bunch of money from the state of North Carolina earmarked, and they need to be able to see what that money's being used for. And publications is one way to demonstrate that. And then funders, really important. There's been a lot of great talks about S10s, the MRIs through NSF, the donors that might be out there that might be willing to throw some money your way to put their name on the wall to support your core. This is a metric that can help generate interest and excitement about the utility of your shared resource. All right, I'm going to stop there, but I want to be sure, I'm just telling the story. A lot of other people did this work, and so Kara, if you're out there, raise your hand. I know she's out there somewhere. Huh? So she did all the work on the manual and now working with Abacus Evaluation, which is our core that's doing all of the automation work and the data visualization. And then the School of Medicine Office of Research strategic investment that we're now at the end of 5 years of a strategic investment. They were willing to invest in our ability to set this up as a new tool. And what our hope is that we can get this up and running and automated, and this is not just for UNC. This is for everyone to have access to and be able to utilize this tool. Thank you.
Pick up the pace.
Did you already open the one from the folder?
Yeah. Oh,
Just hit presentation mode.
okay.
This one's mine. Hello, that actually advanced, that's good. Yes. So I'm Jeff Weiss, I'm the Director for Research Core Planning at Northwestern University's Feinberg School of Medicine. About half our core facilities are in the School of Medicine. We have about 60 or 65 cores overall, but I'll be showing data that represents the cores program for the entire university. There we go. So research at Northwestern is growing, and it's growing fast. In our last complete fiscal year, we broke $1 billion in sponsored awards for the first time. That includes over 1,900 awards to nearly 700 different PIs. And all of this is supported by this constellation of 65 core facilities that are spread across the 2 campuses in Chicago and in Evanston. Not surprisingly, it's expensive to run that program, and the university provides pretty substantial operating subsidies to keep the lights on, or to keep the instruments and services provided by the core what we would call affordable. We're never trying to make them cheap. We're trying to charge as much as we can, but make the services available in a range that the PIs can afford to use them. So let's see. Looking at the recharge income and expenses in our core facilities, this is directly out of our core facilities management system. You can see we turned over about $37 million in services last year. It's roughly balanced with the revenue that came into the cores. This is the revenue from our internal users, a little bit less from our external users, but it balances only because we put in this big dollop of nearly $6 million. And in order to justify that continuing investment, it's important to demonstrate to the leadership, who I have to go to every year with more than just sort of pleading, that the cores are meeting the needs of our investigators. If we're meeting their needs, then presumably the investment is worthwhile. So we have 2 primary measurements of a successful investment that I'll talk about. One is utilization, and it's not just the raw utilization. We know that they use the cores, but we want to know that the investigators are using the cores because they want to and because it meets their needs. They do have choices. In addition to our own cores, we're part of a consortium, which means that they can go to universities in Chicago and get internal rates. And so if the sequencing core at the University of Chicago is better than ours, they can go there and get their samples done instead of sticking with our core, and it's just as easy to mail your sample across town. There's obviously cores at other universities and commercial providers. And then a little bit later, I'll talk about whether people are actually happy with the services that they're getting. So I like to stop just for a moment and talk about data. So to do any of this analysis requires that you have data. And when you go to put your reports together, it's too late. I mean, you have to put the structures in place in advance, knowing that you're going to want to do this type of analysis. So the business reporting system at Northwestern is Cognos. There are obviously already financials and awards, data marts. When we built our cores management system, which we call NewCore, around 2010, in parallel with the application, we built a data mart that would host all of the data from NewCore so that we could merge it with the awards and the financials data, knowing that we'd want to bring those things together. This got a real boost in 2016 when the university site licensed Tableau, which Chris mentioned a little bit. This is a data visualization tool, but one of the things it allows us to do is take the data from the 3 systems and actually blend it and then display it in the dashboards, much like the one that Chris showed you a couple of examples of in his presentation. And that really has been transformative for us. So I'm going to focus largely on the sponsored awards, the ones that are funded by outside organizations. So if we look at the billing in NewCore, there's roughly about $31 million. About 3/4 of it are from our own internal users, and I'm going to focus on them, and about 1/4 of it is from external users. If we dig a little bit deeper into that internal use, you can see about 2/3 of that, or half of the overall activity, is from sponsored awards. The other third of this is startup packages, various sorts of endowments, gifts, internal funds. So for a couple reasons, I'm going to focus on these sponsored awards in this talk. So if we take the data from our core facilities management system and go straight into the award system, and we do that via the financial accounts, which actually are present in all 3 of these systems, we can see that about half of all the sponsored awards take advantage of a core facility, meaning that they had some connection with a core. And that's good. That's a nice number to put out there, but it doesn't really tell you how much they're taking advantage of the cores. To do that, we have to dig into the financial system. So if we take those financial accounts from the course management system and now go directly into the financial system, we can actually look at expenditures and how the investigators are choosing to spend their money. So there was about $600 million in expenditures. The largest portion of that is salaries, tuition, stipends. These are things that you don't have any choice over, right? I mean, you have to pay your salaries, and so we'll put those aside. There's a block of outgoing subcontracts. Again, this is money that's just passing through the universities. You don't have much control over how that's spent. But there was $140 million in what I would call discretionary spending. This is the money that's left over after salaries and after contracts that the investigator gets to decide how they're going to spend to get their research done. If we go a little bit deeper into the financial system and look at how that discretionary spending occurs, we can see that the second largest category of spending after lab supplies and hardware is laboratory services, which includes all of the core facilities. There was about $21 million spent in the core facilities in fiscal year 23. That represents 15% of this discretionary pool, and it's the second largest amount. We can actually hone this a little bit more sharply in that not all of the awards actually need core facilities, right? And so if we look only at the awards that used any sort of a core facility, so now we can ask a more focused question for investigators that use cores, how are they choosing to spend the money? We're now down to about $340 million in expenditures. That discretionary spending is now about $100 million, more or less even. If we break that out, the amount in the cores, it's the same $21 million, but now it's 21% of the discretionary spending. So basically, for awards that use lab services at all, they spend 1 out of every $5 on laboratory services. And so it's a huge category for them. And then the question, of course, is where do they spend those dollars? And so to do that, we went a layer deeper in the financial system. This was quite an exploration for me, trying to understand how the financial system works, because I think somebody said earlier, scientists really don't like finances. Putting aside a couple of smaller categories, we can see that the external vendor expenditures and the expenditures that go into Nucor, our core facilities management system, about 3/4 of the expenditures in laboratory services are made at our own core facilities. So not only are we capturing 3/4 of those dollars to recirculate in the university, it implies that the core facilities are able to meet 3/4 of the needs of our investigators just with the facilities that we have on our campuses. I don't really have anything to compare that against, but to me that's a pretty good number. So my justification to our senior administration so far based on this would be that the direct operational support, that is the subsidies to the cores we provide, are only 15%. Yes, it's $6 million, but it's only 15% of the cost of operating the cores, right? We've got a cost recovery of about 85%. Every dollar of direct operational support transferred to the cores supports $51 in sponsored awards. I don't know how important that is, but I like the way that sounds. About half of our sponsored award portfolio is dependent on core in some capacity. Excluding salaries and outgoing subcontracts, lab services are the second largest category of spending on the sponsored awards. More than 3/4 of that spending is captured by our internal core facilities. And these are the bullet points that I give to my boss, who's the Vice Dean for Scientific Affairs, when he advocates for my budget every year to fund the core facilities. So changing gears a little bit, so people are using the core facilities, and we like to think they use them because they like the high quality of the service and the convenience, but we don't really know that. And to find out how satisfied they are with the core facilities that they're buying, we need to ask them. So we established an annual user survey starting back in 2009 with just 14 cores. The following year, we went university-wide with the survey, and you can see there are 50 cores enrolled at that point. And it's increased gradually since that time. In 2014, we began using Qualtrics, which is a commercial survey tool. So I would consider this the modern era of our user survey in the sense that we standardize the questions and we can compare the data and the responses over the years beginning at that time. There's currently, let's see if I can read that number. I think there's about 68 facilities in the user survey, in the most recent user survey, which we did in February of this year. So the responses have gone up over the time, in part because the number of core facilities has risen, but that leveled off and the number continues to go up. And so we've spent a lot of effort in making people understand how important it is to respond to the user survey so that we can use this data to inform the cores. We do create from this not just high-level metrics for the administration, but we send a report to each individual core facility that shows all of their responses, comments, and things like that. So in our last survey, again, in February of this year, there were about 1,400 people that responded. They provided about 3,200 individual core reviews. Each person reviews a few cores on average. And so it's a pretty robust data set. There are a lot of sections to the survey. There's demographics, general use questions. We do ask people to tell us what future needs they have. Are there things that we provide that you don't use because you don't like them, or the things that we don't provide that you need, or the new core facilities you want? But I'm going to focus just for a couple of minutes here on what I call the heart of the survey, which is what they think of the instruments, services, and staff, and how they feel about our pricing. So the survey has 11 questions. They are broken into these three groups: instrumentation, services, and staff. And they're all posed as positive comments. Instruments that I need are generally available. The core has an easy, efficient process to request services. And again, these questions have largely been static since about 2014. There were some small changes. The responses are on a Likert scale, so you strongly agree, disagree, so forth and so on. We convert those to a numeric score so that we can get a number that we can show people. And these are the results from our most recent survey. So just to give you some context here, the 11 questions are here across the bottom. The black bars show the responses or the scores for an individual core on each of the questions. You can see that most of the cores score in the 4 to 5 range. We do have some laggards here. Obviously, these are the ones that we're concerned about. The mean of all cores for 2023 was in blue. In red is this year, so it hasn't changed too much from last year to this year. But I would call your attention to these scores. They're about 4.5, between 4.3 and 4.6. That's pretty good. What that implies is that for each positive statement that we put forth, half of the people agree and half of the people strongly agree, with the exception of these few exceptions here. Not surprisingly, the things that people are least happy with, instruments that I need are generally available. There can never be enough flow cytometers. There can never be enough confocal microscopes. Everybody wants to get on tomorrow. Services are provided in a timely fashion. You can never get people their data fast enough. But even there, the scores are pretty good. They're around 4.3. So this is the historic trend for the survey. So the blue bar shows the weighted score. And so you can see it is continued to go up. It's starting to level off, but it's still rising. And again, it's sitting at about this magical 4.5 point where, everybody, or on average, people either agree or strongly agree with the positive statements. This is staff. Instruments and services are down here. So people have always been happier with the staff than necessarily the instruments and services, but you see they've risen and they've nearly caught up, right? And so we can say that people are pretty happy with the core services. And this is actually very important to the administration because, every now and then I'll get these emails forwarded to me from the vice dean that I respond to, and he'll say, well, the dean heard from the chair of biochemistry that nobody likes the so-and-so core, right? And their services are terrible. And I'm like, well, that's just not true because here's the report. Here are numbers. We've surveyed 250 of their users, and they actually like that. Yes, there were 2 people who complained, right? And you just spoke to one of them. But we have quantitative data. It's not just our opinion about whether people like the cores or don't like the cores. Pricing is kind of interesting. So these are the 4 categories. We ask people, is it a bargain, which we don't really want it to be, right? We're not giving away services. It's expensive. Is it way too high? That's not good because then people can't use the core facility. Is it appropriate or is it tolerable? You can see that less than 10% of people combined say that the services are either a bargain, which they'll never admit to anyway, or way too high, which they'd be happy to tell you. So I'm glad to see that that number is not too high. More than half, between 50 and 60% of people think that the rates are appropriate, and another 30 or 35% think that they're tolerable. And this really hasn't changed much over time. And so people are relatively satisfied with the cost of using our core facilities, and that's important. So I would add to our funding justification summary that in addition to quantitatively this being a good return on investment for the institution, users are satisfied with the quality and the cost of the core services. They're using them because they want to and because it's meeting their needs. And my conclusion from all of this is that supporting core facilities is a very good investment that clearly furthers the research program at Northwestern. Give me some more money for next year. Thank you.
looks like it's working.
Great. Well, I'm mindful that I'm standing between you and happy hour, so I'll try to be snappy. Yeah, today I'm going to actually do a case study based on the University of Minnesota Genomics Center. And just a few kind of quick things. So this is a university-wide center and core facility, and it's actually housed under our office, Research and Innovation. And it's directed by Dr. Kenny Beckman, who's my co-author, and he's here in the audience. And we actually have about 40 FTEs that work in the core, of which 35 are funded through to user fees for fee-for-service basis, and 5 are funded on grants. And it's one of our larger cores at the University of Minnesota, serving about 600 unique PIs, about half of which are internal to the university. And it completes about 2,000 projects per year. This just shows the org chart and where UMGC lies, and that's within our Research and Innovation office. They actually have a direct report to the VP for Research and Innovation, but there's this dash report to me as the AVP. Now, just to give you a quick rundown of the goals so you can kind of understand the context of what I'm going to talk about today. A lot of the goals from UMGC really provide access to technologies to really drive research. So one is to access and assess and acquire emerging technologies. We'll talk a little bit about that. Advise people on appropriate technologies. Provide the research services, both for internal and external users. Develop novel approaches through their own R&D. And support clinical translation and actually translate discoveries in genomics. These are some of the services. I'm not going to really talk about them in detail, but just want to put up there so you can kind of see generally what kind of services are on offer. And these days, most everything kind of falling into this next generation sequencing domain. And then 2 other kind of interesting functions of UMGC. One is the innovation lab. So that's that piece I was talking about of the kind of driving innovation. This is where the FTEs are funded on grants. And this is really more of a research group within the UMGC rather than a service. And what they do is develop novel tools and technologies. So for example, they've developed novel microbiome measurement, which actually then led to a startup company. They also develop new tools for emerging technologies. So one really hot one now is the kind of long read and single cell sequencing applications. And then the other thing that they perform, which is a free service, is the collaboration. This is a new development, relatively new development. They're actually expanding it. But this is to provide training, instrumentation, and bench space to researchers who want to learn how to do some of these techniques on their own. And so there's this kind of hands-on training for genomics-based approaches. And then also just to have this opportunity for maybe serendipitous interactions to drive collaborations. So I'm going to talk about decisions throughout the technology life cycle and some different metrics that can be used for this. So on the front end, we have the emerging techniques and technologies. So I'll talk about using PubMed citations and user questionnaires to look at those. And then the ever thorny issue of sunsetting techniques and technologies, and talk about how the core uses user data to help inform those decisions. So on the front end, the PubMed citations, this is obviously one that's you can just go and get for yourself, going into a PubMed search. So I'll just kind of show an example. This is from Southern Blot. So Southern Blot is a method for detection and quantification of specific DNA sequences developed by Edwin Southern. That's where it gets its name from. And this shows the kind of full life cycle, I think, of a technique kind of developing and then falling off based on the PubMed citations per year over time. Now, in terms of when you want to jump into the game using this metric, you really want to be on the front end, right? That's the ideal. You want to maybe a technique's around enough that you feel like it's solid, but you really want to get in while it's still accelerating. Where you might say, like, well, why wouldn't you get in at the peak, right? That's when it's at its best. Well, the problem is it's too late for a couple of reasons. One is that these PubMed citations lag what's actually happening in the core by several years. It takes a couple of years to publish your data, and then a few more years to really get citations rolling. So at this stage, what the peak is actually reflecting what happened in the core several years ago. The other thing is that our cores really want to give our researchers a competitive advantage. That means we want to be out ahead of everybody else. Maybe not so far ahead that we're taking too big a risk, but generally want to be out ahead. So I'll just show the northern blot. So we're southern blots for DNA, northern blots the companion for RNA. I think they were being cute because, you know, southern, northern, right? But you can see this technique emerged just a little bit later. It also went through a life cycle, you know, kind of peaking just a little bit behind actually the northern blot. So why did these techniques rise and fall? Well, because of the genomics era, which actually was the development of these higher throughput sequencing methodologies. It's just worth noting as a little bit of a side, this is showing the PubMed data for Western blots, which actually have not had this life cycle as yet. They still are like going strong. And Western blots measure proteins. There hasn't really been a proteomics era of the sort that the genomics era had. So maybe someday, the Western blots will fall, but not yet. So I'm going to kind of walk through the evolution of UMGC. So I'll go through this fairly quickly, but just want to show you how UMGC sort of started and where they were kind of buying instruments relative to this PubMed search data. And just to give you a sense. So UMGC started in the mid-90s, and they kind of jumped in with the Sanger services, which are now been shuttered. And you can see at this stage, it was a new core, so it was kind of coming in when these services were really, maybe really coming a little bit late, but still on the rise. And as I said, that did get shuttered in 2021. But now, like once the core sort of got established, you see they start jumping in much earlier. So expression arrays, they're really on the early end, getting that when it's like on the early end of the rise. Genotyping, also getting into the game a little bit earlier. Next generation sequencing, they really jumped on and got involved very early. And this, by the way, just shows, this is an interesting one, the next generation sequencing. They sort of got involved right about the time that they were sort of thinking about phasing out the microarrays because it functionally replaced microarrays as a technique. And then more recently, now we're looking at the long read sequencing, so jumping in really kind of on the early stage on that as well. Now these PubMed searches, they tell you what's happening globally in the field, right? Are researchers in general, showing an uptick of this technique? But they don't really tell us, does University of Minnesota researchers, do they want this technique? Are they ready for this technique? So to complement the PubMed search are the user questionnaires. That lets us then get at our specific users. And this is something that our director has done as a part of funding requests when he wanted to buy major new instruments. So this is one from a few years ago that was actually approved. And this was assessing whether single-cell genomics tools was like, a good move for the university at the time. So one of the questions that was asked is simply, do you think that it's a good idea for this university, for U of M, to have single-cell genomics instrumentation? So this is an easy one. People say 90% say, yes, I think it's a really great idea. Then you say, well, is this really critically important for your research? And we see about half of people who answered the survey said, yes, it's critically important for my research program. And then there also was additional questions about specific instruments. So how likely are you to use it? So 77% said, high probability or certain that I would use this one instrument, the C1 instrument. And then about 75% said they would use the biomark instrument. So this is like really good support that not only is this a hot emerging technique in the field, but also our research community is really prime. They're ready for this technique. They're going to probably use it. Okay, so now let's move to the other side of the equation, the sunsetting of techniques and technologies. This one, as I said, is a little bit thornier. And for this, really, the approach that our UMGC has taken is to look at the actual user data. So here there's two different things that you can look at. One is the actual number of jobs that are being done per year, number of projects. And the other is looking at the revenue. I think it's important to look at both of these because you can see it's not always the case that like number of jobs and revenue really like scale together. So here's a case for array expression where you see it sort of fell off and seemed to have been down for some time, moving into the kind of 2017 to 2020 timeframe. This is one too where the revenue that was being generated now had kind of fallen down to about the 100K range. Interestingly, this RNAi project count, so it actually has a kind of healthier number of projects, kind of falling down to maybe more in the 50 to 100 range. But look here, the revenue being generated by those projects is only 5 to 10,000. Like, is it really worth it, even if you're running a lot of projects, to keep a technique that's only really, where the service is only generating like a tiny drop in the bucket? This is another one, genotyping use over time. So you can see that that was kind of stable around 60, although sort of maybe dropping off a little bit. But it's generating quite a lot of revenue, right? $500,000 to $1 million. So, maybe that's when you don't phase out as readily. Other issues, so one thing that has been looked at is the cost per run. So that kind of really gets at that, like how much of a load is it really placing in terms of on your system, in terms of what it costs to actually run one of these, depreciation costs for the instrument, and also age of equipment. If you have something that's sort of falling down and it's old enough where you're facing a decision you might have to replace it, maybe that's a good time to just phase it out. I think that as a state university, we have to move carefully in phasing out platforms because there are some stakeholders who are always going to rely on the older techniques. And I think as a community resource, we have this kind of mandate to provide that. So I think you have to have kind of long lead times and give lots of notice when you're going to phase out. I think there's also responsibility of funding agencies. Somebody could have a grant that involves that. So, we kind of promised that we would supply that resource. So I think it has to be kind of just approached with a long lead time and with caution. Also, the other thing is to look at competing technologies, because that can tell you maybe you can transition people over into a new technology. So I already showed you one example of that with the PubMed search, but here's some examples from UMGC. So this is a competing technology. These are pre-analytical workflows, extraction for techniques like microbiome. So you can see that those have really been taking off in the core, both in terms of revenue and project count. Next generation sequencing, really taking off in the core. Genotyping by sequencing, another high throughput genotyping method taking off. Single cell, right? Single cell is very hot, right? That's been really taking off. And what you see kind of happening with UMGC from 2010 to 2015 is it really transformed into being a next generation sequencing shop. So you can see these older techniques are sort of, have fallen off to a low level of uptake. At the same time, this next generation sequencing is just skyrocketing. And that's also associated with the core really growing. So you can see revenue growing over that time from around 2 million up to about 7 million. And also in 2015, crossing this milestone of 1,000 projects, and we're now up to 2,000 projects. So just to kind of put this in a cartoon form, you can see like maybe 2010, this next generation sequencing was on about the same footing as some of these older techniques. But by 2015, it had completely taken over the space. And then moving a few years later, now we see that largely have like sunset the other technologies. So just to kind of summarize, I think it's possible to use both internal and external metrics to decide when to invest in and shutter techniques, especially with regard to investing, where you can get data from the broader research field, like the PubMed citations. I think decisions to invest are inherently kind of risky, but they're not nearly as thorny. On the other hand, decisions to sunset are inherently complex. And I think you need to consider trade-offs as demand for new technology rises that eats up the market for your older technologies. And that's a place, by the way, I'll just mention where I think things like the CoLab can be a really good thing, where you can maybe help train people in terms of how to transform their research programs. So I will close there.
So yes, definitely want to give some time for questions here while everyone sits down. You can see how much effort goes into to creating these metrics. And I think you can also see that leadership now expects to have solid numbers when they make a decision, right? If they're going to take a bet. And so it's really important that you're working with your institution so that you have good metrics and that that your data is clean. So I don't know, we'll start at the front.
I don't think your mic's on.
All right, can you hear?
Yes,
Yeah,
there you go.
okay, great. So after you showed all those beautiful metrics, I was wondering what you need to show out of that to get an objective figure for how much money you need to ask for next year. If you're going back to your advisors.
More
or
than
to your-
last year.
Yeah, but what was, is there a way for you to define that?
Yeah, so, I mean, the way our course program works is I have a defined budget, and we have a competition for funding every year, and the core facilities are all trying to get a piece of that pie. It's very formal. We have a committee, a rotating committee of faculty that review the applications. And so, barring a request by me to expand that budget for the next year, they match the previous years. And so what I'll do in anticipation of a funding round is look for places where, for example, I know that this year our imaging facility and our genomics facility both need quantum increases in their funding just because their activity has grown so rapidly. So I'll ask for that to be added to the budget, but then I have to shoehorn it in. So there isn't a direct relationship between what I see here and how much money I ask for. It's just justification that whatever I ask for is going to be put to good use.
Okay. Hi, Anita Bandrowski from the RID Initiative. This question is for Chris. So it's a little bit multifaceted. First, when you say, what you pointed to is that the core directors should be maintaining their records. The first part of that is, are you asking them to maintain those records in a separate place, or are those being maintained on the core marketplace or the RID where they interact with each other? And if so, could we move that to the ABRF core marketplace, because they are also asking for that same, record to be maintained, so it would be kind of sad to do it in multiple places.
I would be disappointed if you didn't ask that question.
You're welcome. Yeah.
So right now, it's local, yeah, but I think it's a great idea to expand it to the marketplace.
And then the second question, in that same vein for you, is so the RIDs, their entire goal is to keep track of citations, right? Now our AI has completely failed when it comes to core names. We almost don't even try. I mean, we kind of try, and then most of them are false positives. So then we have to get rid of those. But if you are developing an AI that would be able to do something with this, which is deeply fed by the cores themselves, do you have a way of sharing that? Because ours works fabulously for like software tools, but for cores it fails utterly. So would you be willing to share that with with us?
Yeah, there's no reason to create this tool, especially if it works, and then just keep it to ourselves. I think as we're in the verification phase right now, I don't have the answer to that question, but we do hope that as we feed it more data with more cores, that the AI generated search terms will be much more robust. I think the thing about the RIDs is getting cores to get one, and I know some institutions have just said, here's your RID, and force it upon them, and that might be a good idea here. But our uptake hasn't been as robust as I'd like to see it for the RIDs.
Thank you.
Matt DeVries, City of Hope. For Chris, as your tool gets smarter with every new data set and every year and stuff, is it going to be able to reach into the past and update publication counts and things? And
Yes.
And then what's the scientific equivalent of filing a new tax return to?
Yeah, I mean, we've gone back a decade to generate the data set that we have now on the manual side. And then we're basically use that manual search of that decade to feed into this new tool that we're building. Here's all the search terms that worked for this decade's worth of papers. And so, yeah, they should be able to go back. We haven't, I don't think we've set up a date range yet, in the tool. And so the idea would be get all the papers that you can now for the current year. The idea would be to, if you want to get them all forever, we were able to do it with the manual tool. We just haven't automated it yet, but that's the plan, yeah.
Natasha Nicolaitis at Purdue. This was also for Chris. Do you have a feeling for how well your tool, or is it capturing papers that don't acknowledge the core at all? So for instance, as an example, they'll say confocal images captured by a Zeiss LSM 880, or even worse, confocal microscopy as in, and then just reference a previous paper. No other mention of the core facility.
So I didn't want to be so bold as to say I think we've overcome that challenge, but I think we have, in that if we use the right terms that have the right proximity, then if the PI did not cite the core at all, and it's not insidious, it's just negligent, if they didn't, we're getting those papers now. We're seeing those papers. But it's through the verification and feeding that database back to say, here are the terms. If they're in this proximity, we know that's a good hit and that's a score. So that's why I put it first on the challenges, right? That's the barrier we're trying to overcome. If you don't get cited, we're still going to find your papers.
Jeff, I think this question is for you. Alex Kramer, University Imaging Centers at the University of Minnesota. On your financial data collection in respect to cores, it looks quite developed these days. I'm curious at inception if you started with the existing institutional systems and were able to find enough evidence to essentially motivate you to move forward with further developing that. But as I look at some of our reporting data, and I know there's other UMN audience here, but some of the financial pieces have a lot of nuances to them. So we aren't able to see everything we might want to, right? With respect to core usage and differences in internal and external charges and things like that. But I guess to simplify this, did you dig in and essentially find the data that you needed to justify moving forward in a bigger way? Essentially starting with the data that you had available to you at the time, and then build on that.
Well, I definitely wouldn't say that we had a preconceived notion of how it would turn out. I was pleased with the way it turned out. It was sort of a stepwise progression, right? So the first thing I thought was, well, I mean, who uses the core facilities, right? I can see how many of the grants touch the cores. And then I would show that, say, the Weiss team, they'd say, okay, but how much did they use the cores? And I would dig back in there and try and find some evidence for that. So I would say over the last 4 to 6 years, we've dug in layer by layer. That last piece, the percentage that goes internally versus externally, I did that this year for the first time. And again, it's just each time you answer a question, it's like, well, that doesn't fully tell me what's happening there. What's the next thing I need to know? We just kind of stepped our way into it.
Did you need to revisit your reporting mechanisms to capture that data better over the course of the years with your financial data, or that was kind of built into what had already been established?
No, I mean, that's the beauty. So Northwestern has decent data systems, right? So we have data marts. We have these Cognos data marts. So the data's there. I've always been stunned. I have 2 jobs at Northwestern, so the other one is the director for research analysis for the medical school. So I do have some familiarity with these things. And there's a lot of data there. People just didn't take advantage of it, right? The other thing is making the connections, right? So one of the things that really facilitated this is that we built our own core facilities management platform, this new core system, which we'll actually talk about on Thursday. And by around 2017, we had full enrollment, which means that all 70 of our core facilities are in there. And that really is key, because then we can look at all the cores and see what payment sources people are using. And then we can take those payment sources and go out to the existing systems, the financial system, rewards management system, and make those connections. If you don't have everybody, then you're only seeing part of the picture. So the 2 key things are making the connections between the data. That part was pretty easy, and making sure that all of the data is there. And that meant building the data mart in parallel when we built the course management system and then getting everybody to use it.
So that final, and pardon everyone, that final layer of adding the new cores on top of the existing enterprise data financial systems is really what helped you get to those insights. Is that a fair
Yeah.
assessment?
Well, I mean, so Nucor is the name of the software, but yes, we got all the core facilities into
Sure.
the management platform.
Understood. Thank you.
I think we have time for one more question, so.
Hello, I'm Carrie from the University of Michigan. And as you might know, we're a very large institution, and often we're going through survey fatigue. So I'm wondering, based upon what you're all saying, how you get people to answer your surveys as a result of so many others out there.
But, so I will tell you, the very first thing I did was shut down all of the other surveys. And so when we started, you know, departments would send out surveys, the Cancer Center sent out a survey, the Office for Research sent out a survey. And when we built the survey in the medical school and then offered it to the rest of the university, and we offered it to the Cancer Center, and we intentionally built into that survey the ability to parse the data in such a way that I can tell you which responses came from Cancer Center members, for example. Now it's self-reported, are you a member of the Cancer Center? But we purposely set it up so that all of those groups could extract, or we could extract for them, the set of data that they need to do their reporting. And then we made sure that the survey went out to everyone, and we asked them in return to not do the other surveys. And if you only ask people once, and you make the survey reasonable, you get pretty good responses. The first year or two, for sure. We got so many, it's like, I just got one, it was from you, no, it was from someone else. So we realized very quickly that we really had to home in on one mechanism.
Yeah, I think the other thing on our surveys is you get one request from leadership saying that this survey is important and that we view it, and then the core directors will send out a separate request explaining how they use the survey data and that it's important to them. And so you kind of get both types of people, right, that want to give a piece of their mind or want to support the core to answer the survey. And I think that's
But it's all
explains part of the
encouraging them
results.
to answer the same survey.
I think
So-
it's lovely that you can shut down all the other surveys.
So I would like to thank our speakers and thank you for all attending.